Hey everyone, so let's start by actively reading the question first and see if we can apply whatever we learned in lesson 3 in this question or not. So the main idea would be to stop making any assumption and solve the question, keeping an open mind and trying to look at all the possibilities. Okay, so let's get started. So let's write down the first step, which is jotting down what information is given to us. So in this question, it's given that p is a positive integer. Okay, so p is a positive integer. Okay, so the values of p can be 1, 2, 3, 4, 5 and so on. Okay, we don't know anything else, and we need to find out what is the remainder when p is divided by 6. So let's write that down. We need to find the remainder when p is divided by 6. Now, since we don't have any other information with us, obviously we cannot do any pre-analysis here, except for, as I told you, just jotting down what can be the values. That's all. So we should directly jump into the second step and start analyzing the statements. Okay, so let's look at the first statement. First statement is p is equal to 6k plus 1. Okay, now what will be the remainder in this case? We know that p is a positive integer. Do we know anything about k here? That's the first question that you need to ask yourself. Do we know what k is? Well, we don't know the nature of k, whether k is an integer or a fraction. We don't know anything. So it makes sense for us to keep both the possibilities in mind, that k could be an integer and also keep in mind that k could be a fraction. Okay, now if you look at both the cases, so if I look at the case when it's an integer, okay, when k is an integer, in that case, when I divide this by 6, okay, and try and find out the remainder, that's very easy for me, because I know when 6k is divided by 6, okay, and again keep in mind k is an integer, then the remainder is 0. And you can check it out. Put k 1, 2, 3, 4, 5. You'll see that it's 0. There's again an elaborate explanation for this, but I'm not again going into too much detail. Okay. And what about 1 by 6? When I divide 1 by 6, I get the remainder as 1. So I can say when p is divided by 6, the remainder is 1 when k is an integer. Okay. But we need to consider another possibility. The other possibility is that if I write it as case 2, which is k could be a fraction or a decimal. In that case, the answer could be anything, and the value of p can be anything. For example, let's say k is let's take k as 1 by 2. If I take k 1 by 2, I'll get p is equal to 6 times 1 by 2 plus 1, which is equal to 4. Now when 4 is divided by 6, the remainder is 4. So you can see that you're getting two contradictory answers. In this case, you got the remainder as 1. In this case, you're getting as 4. And you can keep on trying. You can say if you can take k as 11 by 6, for example, then in this case, it would be 6 into 11 by 6 plus 1. This is 12. And 12 divided by 6, the remainder in this case is 0. So you can see you can get multiple values depending on the nature of k. And in the question, nothing has been given about k. Now, a mistake that most of the students will make, especially those who haven't gone through the lesson, what they will do is they'll make an enforced assumption here. They'll think, okay, 6k plus 1, and subconsciously they will think that k is an integer. And the moment that they do so, and they put values such as k is equal to 1, k is equal to 2, k is equal to 3, they put only such values, they will say that the remainder is 1 and mark the answer as A. Okay, and this is incorrect, as you can be seen here. So we'll say statement 1 is not sufficient. If statement 1 is not sufficient, our answer cannot be A, our answer cannot be D. Okay, now keeping this in mind, we'll move on to statement 2, and let me write here this here only. Now here is simply given that p is greater than 3, and I need to find out the remainder when p is divided by 6. And it's very obvious this will be not sufficient, right? Because p can take multiple values. P can be 4, p can be 5, 6, 7, 8, and all these gives us different remainders. So in this case, I can say statement 2 is also not sufficient. Now when I combine, I'll try and see if I'm getting a unique answer or two different answers. Now notice I have two cases here where p is greater than 3. And notice in these two cases, I'm getting two different answers. In one case, I got p is equal to 4. In another case, I got in one case I got the remainder as 4. I'm really sorry. And the other case, I got the remainder as 0. Okay, it's quite possible if I put k as 1 in this case also, I'll get 7. Here, I'll get the remainder as 1. So if p is greater than 3, and if I consider the first statement with me, even then also I cannot say what will be the unique remainder, and hence the answer in this case will be option E. So this question is based on a typical A trap where the statement is created keeping in mind that you'll make an assumption, and that assumption is that you look at a variable and you assume that's an integer. If you do so, you'll mark as A. If you stop yourself from doing that, you'll definitely see there are different cases and mark the answer as